So jump and call instructions, jump instructions, take down the instructions, branch instructions, branch instructions, branch instructions are used to change the sequence of the program. Branch instructions are used to change the sequence of the program. What is the purpose of this branch instructions? Okay, they are used to change the sequence of the program. There are two varieties of branch instructions. One is a jump type, other one is a call type. One is a jump type, the other one is a call type. Jump on carry, jump on zero, jump on no zero, okay, jump on bit, jump on no bit, okay, decrement, jump on no zero. All these are examples of jump instructions. Okay, once again, so these are the jump instructions. JZ, jump on zero. J and Z, jump on no zero. JC, jump on carry. JNC, jump on no carry. JB, jump if bit is 1. Jump if bit is 1. Jump on no bit. JNB, jump if no bit. If the bit is not 1, you take a jump. Okay, so JBC, jump if bit is equal to 1 and complement that particular bit or clear that particular bit. This is one such a, all these are the varieties of jump instructions. Apart from this, there is one unconditional jump called as, there's one unconditional jump called as SJMP, LJMP. These are unconditional. No need to check any condition. No need to check any condition. Okay. So branch instructions are used to change the sequence of the program. Write short notes on branch instructions with one example each. Right? So branch instructions are used to change the sequence of the program. There are two varieties. One is the jump type. The other one is a call type. The first one is a jump type. The other one is a call type. Okay. So if that is a jump type, the first one is a unconditional jump. The next one is conditional jump. Conditional jump. So these are the two varieties of jumps. Conditional jumps, unconditional jumps. Unconditional jump means no need to check any condition. Example is SJMP, AJMP, LJMP. Okay, L jump, short jump, absolute jump. Okay, we mainly concentrate on S jump and L jump. I will tell you what is absolute jump, but we don't use that much. S jump, short jump, absolute jump, and then long jump. Now, conditional jumps are jump on zero, jump on no zero. If the result is 0, then it will take a jump. Jump on no zero. If the result is not 0, then it will take a jump. Jump on 0. If the result is 0, then it will take a jump. So similarly, JC, jump on carry, jump on carry. Okay, jump on no carry. Okay, so jump on bit, jump on no bit. All these are the varieties of conditional jumps. Conditional jumps. Okay, before taking a jump, before taking the change of the sequence, this instruction will check whether the result is 0 or not. If the result is 0, then it will take a jump. Okay, jump on no 0. If the result is not 0, then it will take a jump. It is checking a condition now. Result is 0 or not. So similarly, jump on carry. If the carry is 1, then it will take a jump. If the carry is not 1, it will not take a jump. So it is checking a condition. What is that condition? One is checking the availability of 0. Another one is checking the non-availability of 0. Another one is checking the availability of carry. Another one is checking the non-availability of carry. Okay. So, and the next one is going to be, again all these jumps are classified into short jump, S jump, short jump, absolute jump, and long jump. Do you know what is the difference between short jump and the long jump? You know what is meant by short jump and long jump? Okay. So repeating a sequence of instructions in a certain number of times is called as loop. You want to repeat a set of instructions? You can't write a 1000-line program. Instead, you write 10-line program. Repeat it 10 times or 100 times. It will get executed those many number of times. It's equivalent to writing 1000-line program. Code length decreases and you can get the result efficiently. Okay, so the next one is if you want to repeat an action more than 256 times, then you have to use a concept called as nested loop. A loop within a loop is called as a nested loop. See here, there is a program. This is what is the loop. This is written inside this loop. This is written inside this loop. Okay, so the first line, this line is this line and this line. Between these two, one more loop is there. So such looping is called as nested looping. Writing one loop within another loop is called as nested loop. Now, okay, the first jump instructions jump only if a certain condition is met. Jump on 0. If the result in accumulator, I repeat, result in accumulator, if that is 0, then only it will take a jump. If the result in B register is 0, it will not take a jump. If the result in R0 is 0, it will not take a jump. This instruction particularly checks accumulator. If the result in accumulator is 0, then only it will take a jump. Right? So the next one is jump on no 0, jump on no carry. If the carry flag is 0, then it will take a jump. JC, jump on carry. If the carry flag is 1, it will take a jump. That is JC. Jump on no carry means if the carry is 0, then the instructions which are there in the loop will get executed. It will take a jump. It will take a jump. If the carry flag is 1, it will not take a jump. That is jump on no carry. Now coming to the next one, all these are all conditional jumps are short jumps. Write down. All conditional jumps are short jumps. All conditional jumps are short jumps. SHORT, short jumps. What is meant by short jump? Again, all conditional jumps are short jumps. The address of the target must be within minus 128 and plus 127. Within 256. Within 256 bytes. Then it is within 256 bytes. Such jump is called as short jump. The unconditional jump is a jump with control is transferred unconditionally to the target location. You don't need to check any condition. That will not check any condition. You jump from 2 to 5, it will take a jump. You say jump from 5 to 7, it will take a jump. You say you jump to 7 to 250, it will take a jump. Such thing is called as, it's called as unconditional jump. Now, LJMP Long jump. Long jump. What is meant by long jump? From any location to any location, no restriction. From the first memory location to the last memory location, you want it to take a break, or you want to take a change. Then such jump is called as long jump. Clear? So long jump is a 3-byte instruction. How many byte instruction that is? 3-byte instruction. The instruction is LJMP followed by 9000, something like that. LJMP 9000. So this is LJMP 1 byte, 91 byte, 00 is 1 byte. So 1 instruction occupy 1 byte or 1 set of bytes. Some student require 2 chairs to be comfortable in the class. So if you give 1 chair, they are not comfortable. Okay, you give 2 chairs, they sit comfortably in the 2 chairs. They occupy 2 chairs. 2 students certain times require 3 chairs. You give 3 stools, 2 stools, 3 students comfortably they'll sit. Okay, how many chairs that they have occupied? Two chairs. Okay, 3 children, 3 students. Some students decently they'll occupy 1:1 chair. Now the college means 1:1. So like 1 chair is given, they'll sit, and so means they are 1 byte instruction, 1 by 1 chair. So L jump is a 3-byte instruction. Now coming to S jump is a 2-byte instruction. That is the difference between S jump and L jump in the aspect of memory. Okay, so now the next one is going to be call. L call, long call. Long call is a 3-byte instruction, just like L jump, L call. From anywhere, there is a program written somewhere. There is a program written in some location, from some location onwards. You want to execute them. You want to leave the present program and jump to that and then execute it. Subprogram. We call that as a subprogram. Okay. How to call a subprogram? L call. L call. From anywhere to anywhere, it will take a jump. From first location to the last location, anywhere. That is called as L call, long call. Absolute call. What is this absolute call? This is within 2 kilobytes. Another one is simple call. Just you give call, that is within 256 bytes. What is A call? 2048 bytes. Within 2048 bytes, that is called as A call. So means if I am able to jump from here to here, that is called as short jump. If I am able to jump from here to the last ray, that is called as absolute jump. If I am able to jump from here to that new block, that is called as long jump. It's just that type of thing that is. Okay, from here to 256 bytes, within 256, that is short. From here to 2048, that is absolute. From here to anywhere, that is long. Okay, so that is the difference between long call, long jump, absolute call and absolute jump, short call and short jump. Short call is call, right? So when a subroutine is called, what is my subroutine? A subprogram, a program which is not part of the main program. Okay, part of the main program. It's not a part of the main program. Okay, so whenever there is a need, we go to that and then we come. Whenever I need an LCD, I will call Michael, ask them to set up the LCD. Okay, but if there is no need of LCD, I no need to call Michael. I will continue with my class. So when I will call Michael, there is a need. 1000 times I need. If this LCD is not working, He will change another one. One more time he'll call. This is not working. Call Michael. No, another time we'll call. So sub-program means a program not written in the main program, separately written. Okay, so that is after executing that program, cursor will come back to the main program again. Okay, see here, lcall is a sub-program. Okay, it's a call. A sub-program is there whose name is delay. So this is what is the delay program. This is what is the delay program. Okay, starting address of the delay is 300. 300. That is given the name as delay. Whenever I want to jump from here to whenever I need a delay, I will use an instruction called as lcall delay. The cursor will leave this place and then it will jump to this. It will execute all these instructions. Last instruction in the subprogram you see, that is read. The last instruction in the subprogram is read. On receiving that, it will come back to the main program. Subprogram, how will you push it to the subprogram? Give lcall followed by the starting address of the subprogram. Okay, the cursor will take a jump to the main program to the subprogram. After executing this particular one, if you give read instruction from subprogram, it will come back to the main program. Okay, it will come back to the main program. If you don't give read, no, the subprogram will become the main program. It will continue with that. You don't. So if you don't know how to where to cut the discussion, your boss will exploit you. Will know everything about you. Wherever there is a necessity to make you work, they will exploit. So you should know how to cut the discussion, come back to your work. So how much ever you are supposed to talk with your boss, that much only you should talk. No, today my mother gave me 3 dosas. They were very nice. No, okay, this fellow is very is good in food. Let me give some food and make him do some more work. They'll deny their own conclusions. So cut short. Okay, so return is to return back to the main program. Return to the main program, right? So clear? So the only difference between a call and L call is the long call can be anywhere within 64 kilobytes, from anywhere to anywhere, whereas a call within 2 kilobytes, within 2 kilobytes. That is the difference. Okay, so that is another one. One instruction will get executed. I told you that L call is a 3-byte instruction, A call is a 2-byte instruction. Okay, you need the microcontroller requires less amount of time to execute a 2-byte instruction, whereas it requires more time to execute a 3-byte instruction. Okay, so that is what is the concept here. So we are going to teach you the delay program in the third unit. Okay, in the third unit. At present, I am not teaching you the time delay calculation. Time delay, how to calculate the time delay, that I will teach you along with the time delay program, timer programming. Third unit, continuation will in a test stretch will continue this. Okay, so for CIA1, time delay calculation is not given, right? So is it clear? Yes. The next instruction is going to be DJ and Z. DJ and Z. Take down the first instruction, DJ and Z. First instruction is DJ and Z. DJ and Z. Okay. What is the meaning of this? Decrement, and jump if not 0. Decrement, jump if not 0. That is what is this particular one. The syntax of this is Take down the syntax of this DJNZ. DJNZ space reg register comma label. Decrement jump if not 0 to this address. Okay, DJNZ decrement jump if not 0. Okay, we try to write a program using this particular instruction. Okay, so now how you can write? Let us suppose R0 is equal to 5 and you want to decrement it till R0 is 0, you want to repeat. Okay, decrement jump on no 0. Decrement. What do you want to decrement? I want to decrement R0 value. First question, decrement. What to decrement? Decrement R0 value. Okay, check whether R0 is 0 or not. Check whether R0 is 0. Okay, so what is the first question? Decrement. Decrement. What to decrement? Decrement R0 value. Okay, decrement R0 value. Second one is check whether that R0 is 0 or not. If that is not 0, if that is not 0, jump to this location. Jump to this location where the name of that location is here. Okay, what is the meaning of this instruction? Decrement. What to decrement? R0 value. Check whether R0 is 0 or not. If that R0 is not 0, you take a jump to this location. Now, next one. Decrement jump on no 0. B, comma, repeat. Decrement B value. If B value is not 0, you go to a location whose address is repeat. Okay, so decrement jump on no 0, B comma repeat means that is what is the meaning. Okay, decrement jump on no 0 at the rate of R0, at the rate of R0, comma over. Decrement the value available in that location. Decrement the value available in that location. If that is not 0, you go to a location by name over. Okay, same thing. So the next one is decrement jump on no 0, 30H, comma, again. So decrement, what to decrement? Decrement location content. The address of that location is 30. Decrement the value available in that location. If that is not 0, you go to a location by name again. I hope I made the functionality of this instruction clear. So DJNZ will do 3 things. First one is decrement. Second thing is it will check whether the content in that register or that location is 0 or not. Third thing is it will take the decision depending on the value. 3 things it will do. Okay. So in the question bank I have given explain the following instructions with examples. Move. We know what is meant by move. We know what is meant by SJMP short jump. We know what is meant by JB jump on bit. Okay. We know what is meant by div-ab. We don't know DAA at now at present. Div-ab division. Decrement jump on no 0. Decrement jump on no 0. We know what is meant by LCall long call. So like this 5 bits, 5 instructions may be given. Ask you to explain about one instruction writing two lines. Okay, write the functionality, write an exam. Two lines, 2 5s 10 marks. Like that, a question can be framed, right? Explain the following exam instructions with examples. Okay, so we'll write a small program using this. Write a program write a program to multiply write a program to multiply 5 and 2. Write a program to multiply 5 and 2 without using mul instruction. Write a program to multiply 5 and 2 without using mul instruction. Because there is an instruction called as mul. You can multiply directly 5 and 2. Why not 5 and 2? Any number with any 8-bit number with any 8-bit number you can multiply. But you should not use mul. That is what is the condition. So how to multiply? Multiplication is nothing but the repeated addition. Okay, so here 5 into 2 is equals to, or 5 into 4. You make it 2, you make that 2 into 4. Okay, 5 into 4 is equal to 5 plus, okay, 5 plus 5 plus 5 plus 5. Okay, that's it. You add 5 4 times, you will get the same result. Okay, so what I do is I take a register, I will load that with 0. I will take a register, I will load that with 0. Okay, I will take B register, I will load that with the first number 5. 5 into 4, you take 5. You take 5 in the first B register. I am taking R0. There is no other register like C, D, E, H. Oh, here I am taking R0. I am taking the, okay, I am taking the second number. I add 5 to A. I decrement R0 value. I add 5 to A, decrement R0 value by 1. I will check whether R0 is 0 or not. If R0 is not 0, I will add again B. 5 plus 5 is 10. I will decrement. I will add. This is not 0. This is not 0. This content is not 0. So I will add one more 5. I will decrement R0 value. This is not 5. So this is not 0. Again I will add. I will decrement this R0 value. Now R0 value is 0. By the time R0 comes to 0, we will have the sum that is 5 plus 5 plus 5, that is 20 in the accumulate. Okay. So this particular program I will write for your convenience, for your sake. I will write this particular program, okay, using that instruction called as DJNZ. What did I do first? Initialize A with 0. What is the instruction to load 0 in accumulator? What is the instruction to load 0 in the accumulator? MOV A comma hash 00H. What is the instruction to load? Okay, 5 in B register. MOV P comma 0F0 comma hash, okay, 05H. Okay, how to initialize R0 with 4? MOV R0 comma hash 04H. Now, what is the first step I have done? I have to add B to A. What is the instruction to add A with B? What is the instruction to add A with B? Add A comma B. Add A comma B. Now what I have to do? I have to decrement R0 value. I have to check whether it is 0 or not. If that is not 0, again you have to repeat. These three things are there. These three things you can do using a single instruction called as DJ. D means decrement. J means jump or no zero. Okay, J and Z. Decrement. Decrement what? R not value. Check whether it is not 0 or not a 0. Okay, if that is not 0, go back to a place. Okay, that is called repeat. I am writing repeat beside this instruction. Okay, I'm writing this instruction repeat that word repeat beside that instruction. Okay, so what is the meaning of this repeat? Repeat is the name given to a particular location, that is called as label. Is there any grammar to label? What is the procedure you have to follow? What can I give my roll number as the label? No. You can't give your 1072 as the label. As the label. You should not give. Not allowed. So it should not start with any digit. One repeat. Not allowed. This is not correct. This is not correct. Okay. Repeat one. Allowed. Allowed. This is allowed. Okay. And repeat dollar. Not allowed. Repeat dollar. Not allowed. Special characters are not allowed. But underline is allowed. Repeat one. Repeat one. Allowed. One repeat is not allowed. Okay. So these are the simple minor things that you have to follow in order to label an instruction. Particular that instruction. Right, location. Label. This repeat is what is called as the label. Now A will be initialized with 0, B will be initialized with 5, R0 will be initialized with 4. Add A comma B. A will be added, B will be added to A. 0 plus 5 is 5. Okay. Accumulator will have 5 in that. Decrement, jump on no 0. Decrement R0 value will be decremented. Jump on no 0. The content in R0 is not 0. So it will go back to a location which is labeled repeat. Then it will execute, again add B, it will again add B value to A. Then it will come back to DJ and Z, decrement R0 value. Okay, if the R0 value is not 0, again it will go back. So like this you can repeat, set of instructions by initializing. What do we call this R0 as? What do we call that R0 as? R0 is called as counter. R0 is called as counter. You initialize a counter and repeat it till it becomes 0. So this is the instruction called as DJ and